Hey guys, what's up? Eddie Aho here with KissAnalog.com. Alright, so this is a continuation of our digital series. Brought to you by Kiss University. Kiss U. I kind of joke about that, but yeah. So the last class I think was D101 for Digital 101. This is Digital 102. We'll call it Digital 102. Kind of a continuation. What I'm going to do is I'm going to first show you the top 3 gates, the most popular gates, digital logic gates, okay? So let's do that. And by the way, I'm not going to use the whiteboard today. I'm going to use this notebook. And yeah, tell me what you think of that. Alright, so hopefully this, leave in the comments below if you like what you see here better than, the whiteboard I typically use. Alright, so let's go back over the 3 most popular gates. I showed you 5 of the gates last time. I'm going to cover 3 right here. These are the most popular ones. Okay, this is an inverter. See that bubble? That's what gives it away. Alright, so usually we use the A, lower part of the alphabet for the input, upper part of the alphabet for the output. So A is the input, X is the output. Alright, now whenever you see that bubble, that means that the signal is inverted. It's a not or it's a bar. Bar, not, inversion, all kind of means the same thing, okay? So there's that bubble. So here we go. X is equal to A not. That's the bar. A bar. A not. Alright? So there's your inverter. Pretty simple. Put 5 volts in, you get 0 volts out. Put 0 volts in, you get 5 volts out. Okay? Could be 3.3, whatever the voltage logic you're using, okay? Alright, so now let's look at the next gate. Okay, let's draw a straight bar. It's kind of hard here. Okay, there's a straight bar. There's our output, and we're going to say it's an X. And the input, we're going to put 2. It could be 3 or more, okay? But the 2 inputs are the most common. So A and B. So X, this time, the output is going to be X equals A and B. Alright, so we use the A and B, like multiplication symbol, the dot, because it is kind of multiplied. So if A is a 1, B is a 1, it's 1 times 1 is 1, right? So if they're both 1s, if you got 5 volts on each one, you're going to get 5 volts out. Or say 3.3 on each one, 2.5, whatever. If you got 3.3 on each one, you're going to get 3.3 out. Okay, it's just logic. Alright, so if they're both 0, 0 times 0 is 0. 0 times 1 is a 0. We have truth tables. I'm going to show you what those are. That is basically all the possibilities of those inputs, what output you're going to get. Okay, let's go over the 3rd gate now. Okay, this is an OR gate. It's kind of a curve. Sorry about my drawing, not so great. But kind of a curved input, kind of curved outputs. And this is going to be A, B. We're going to use the same thing, and X again. This time X is equal to A or B. Alright. So, in this case, we have a plus sign because we're adding. So, if A is a 1, B is a 0, A plus, 1 plus 0 is 1, right? Or if A is 0, B is 1, you got 0 plus 1 is a 1. Pretty simple, right? OR gate. So, this or that, either one of those 2 things is 1, you get a 1 out. It's an OR. And like we said before, it's and. You have to have this and that to be a 1. So, or to be a high out, okay? Alright, so those are our 3 most popular gates. Let's look at the next 2. These are the 5 gates I showed you before, but those are the 3 most popular. Let's look at the next 2, okay? The next 2 looks like an and, okay? You guys probably guessed what this is already if you saw my last video. Looks like an and, right? I'm going to put a little dot there. Okay? So we got a bubble. So what that is X is equal to A and B, same thing as before, with a bar over both letters. Okay? That's important to show it that way, not a bar and a B bar. Okay? It's A and B with a bar across both. That's important. I'll show you why later. But anyway, probably next video I'm going to break down all this stuff and show you why, okay? But for now, just remember, that's important. So essentially, the AND gate is this. It's AND, going into an inverter. And there's your bubble, okay? So that's why it's done that way. Okay, now let's look at the next one, the fifth one. The OR gate again. Again, my drawing kind of not too hot, but I think you get the idea. So X is equal to A or B. But again, I got to put the bubble in there, okay? And then we put a bar across the whole thing. All right. So now here, let me show you the other way to do it. Why we're doing, got to have a curve. And then this is kind of curved up, and this kind of curved up. And then we come out to our inverter with the bubble. And there, okay? So that's the same thing shown with two elements instead of just putting a bubble on the end. So it's the same thing. All right, so there you go. There's the 5 gates I showed you before. All right, so now let's go to actually, you know what? Let's go to the truth table of these 5. Let's just cover that, okay? So let's go another page, and I'm going to go to truth table. Okay, so for the inverter, what a truth table is you have the inputs, however many inputs you have. In this case, we just have 2, and our output, we just have 1. For the inputs, they can both be 0. Okay, we're going to cover all cases. So what we're really doing is just doing math, okay? And we're going to go to the next page. I'm just going to go over the math, okay? So let's say we're base 10, the way we normally count. 0 through 9, then 10 through 19, and then 20 through 29. So we go that way, okay? Sounds a little different the way I'm saying it, but it means something, okay? So let's say normally we would go 0. We count 0. 0's something, right? If you pull in a parking lot and the attendant says, yeah, there's 0 cars here, that means something, right? So you start counting with 0, okay? It's important. So then we add 1 to that, plus 1. So then we get equals 1, okay? So first we have a 0, okay? We start off with 0, and then we go 0 plus 1, and then we take that 1 and bring it over here, and we add another 1, and we get 2. And we keep on doing this until we get 9 down here, right? And then after that, what do? We carry 1. So then we got a 10. And then we keep on adding 1s. So the next one's 1. We added 1, add another 1, and we go down until we get to 19. And then we carry 1, and we get 20. Whoops, my notebook doesn't want to let me do a 0 there. There we go. Yeah, it didn't let me do a 0. Sorry, that's a mess. Okay, so in digital what we do is we only have 2 things we can count. It's either high or low. Okay, let's start off with low. We start counting 0 just like we always do. We can only count to 1. So now we got to carry 1. So we carry 1 over here, and then we put a 0. And then we add 1 to that, and we end up with that. Then we add another 1, so we have to carry it. And it goes like this. Then we add 1, does that. Then we add another 1 to that, and we end up with this. Add another 1, we end up with that. And then we end up having to carry again. Kind of see the strategy here? So now check this out. Okay, I'm going to put a 0 here. I'm going to fill in the zeros in front, just like I could with base 10 stuff. Put zeros where it doesn't matter. So we have 3 columns, and I just fill in the other columns with zeros. All right? Now look at the... you can kind of see what's going on there. There's a pattern, right? Just like in base 10. On the far right side, the lowest digit, like let's say if we count to 599, or let's say 592. The 2 is the smallest digit, right? It's 2. We got 500s, we got hundreds columns, then we got the tens columns, then we got the ones columns. Well, the 1 column, it's the least significant digit, right? If we're plus minus 1, it doesn't really matter a lot. If we lose $1, add $1, yeah, not as big a deal. We don't want to lose that number on the left side, 500, right? We don't want it to be 400. That's the most significant bit. Most significant digit. You see what I'm saying? So I'm kind of leaning into the digital talk. So in digital talk, the number on the far right, just like in dollars, just like in base 10, the number on the far right is the least significant digit or least significant bit. These are bits, so we call them bits, okay? Each one of these things is a bit. The number on the, the number to the far left, whichever it is going to be the most significant, just like in base 10. All right, so there's some terminology we're getting used to. So let's go back to these truth tables. So let's just count it. So we add one, we add another one, so we carry, then we add another one and we get this. So that's what they look like, okay? Let's just call this the AND gate, okay? This is for the AND. That's AND X. And then we'll go to the OR over here, okay? So I can show you the same thing with the same inputs, okay? So I'll just draw a line like this and draw it over like this. So for the OR, we have there AND here. So 0 times 0 is 0. 0 times 1 is 0. 1 times 0 is 0. 1 times 1 is 1. So that's a truth table, what we call for the AND gate. That's what's going to happen. If you have to put a high on both A and B to get a high out. So that's an AND gate. On the OR, we're ANDing. So we're adding. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. And 1 plus 1 is 1. So there you go. So that's the AND OR, okay? Now, the NAND, before, when I showed you the NAND gate with the bubble on the output, the inverting AND gate, that's what we call the NAND. And then the NOR is just the inversion. It's the NOT function. That bubble is a bar or a NOT or an inversion, right? So when we say NOT, it's a NOT AND gate or NOT OR gate, okay? So now if I just do the table again, A, B, X for this one, X for this one, and draw the table, okay? Then I have 0. I start counting at 0. And then I add 1. Then I add 1 again. Then I add 1 again. I get that, okay? So you can kind of see what's going to happen is the inversion of the AND or the OR, right? So all we have to do is change the zeros to ones and the 1 to zeros. So we go 1, 1, 1, 0. That's the truth table. Then 1 on this one, 0, 0, 0. So those are the truth table is what we call them in digital, okay? You know, if you put those inputs, that's the output you're going to get. And the way we do it is we just look at all the possible options there are. And the way we do that is we put them down there. And all you have to do is count from 0 until where you have all zeros to where you have all ones. So you count that high to where if we had 3 places, A, B, C, you'd start with all zeros and keep on counting until you get all ones. Once you've done that, you've got all cases, all right? So that's how it's done. And I'm going to show you that in videos to come. We're going to look at some real circuits, break them down, okay? All right, so essentially I've covered what I covered in the first video. You know, maybe a little quicker. Last video you might want to look at. Still a pretty short video, like hopefully this one is going to be okay. I want to show you 2 more gates. These are, it's really one gate, and the second one's the inverted version of it, just like the AND and NAND, or the OR and NOR. And I guess, you know, it's not really a digital thing, but an analog thing. The inverted gate, I guess in analog situations, there is the other version of that, which is just a buffer. It's just, you put a 1 in, you get a 1 out. The only reason you use a buffer is because if you want to drive something, you know, you want a low impedance on the output, something higher than you can drive with your digital output, you'd put a buffer there. So I guess you could also say there's a buffer, but that's not usually considered a gate, okay? But I guess maybe technically you really could call it a gate, whatever. Okay, let me show you the next really cool gate. This one's kind of cool, kind of different. Okay, so what you have is kind of a curve like an OR gate, okay? Kind of curved lines like this, and then an output. But what's different than an OR gate is you also have another curve here, and I'm sorry my drawing's so bad, but I am kind of holding this in my lap, and you got an A and a B and your X. Let me show you the table, okay? A, B, X. Okay, we'll start off with zeros, and then we add 1, we count up until we get all ones at the bottom. There we go. And then what are the options? So X OR. This is interesting. I'm just going to show you what it is. And then we get a 0. So instead of the OR gate where we get 1, 1, 1 all the way down, when you get 2 ones, it's actually a 0. That's kind of interesting, right? Let me show you something math-wise, okay? Each one of these things we could write, okay? We could go A naught, because 0's a low, and then it's and a B naught is equal to X. That's what that first one shows, okay? And we know X is equal to 0 in this case, so we'll put a 0, all right? Then the next one is A naught and B is equal to 1. So there's one place we get a 1. And then here's another place. A high and B low, which is a naught, is equal to 1. And then we got A high and B high is equal to 1. So, pretty interesting, huh? So if you look at that, you get a 1 if the A naught and the B is equal to 1, or if the A and the B naught is equal to 1. So how do you write that? You could go A naught and B, you get a 1, or, which is a plus symbol, A and B naught. Either one of those, you get a 1. All right, guys, so let me show you something. We're going to redraw that, okay? So I'm going to put the equation right here, A bar and B, or if we have the A and B bar, B naught. So you could say A naught and B, or A and B naught would be equal to 1. Either one of those cases, it's an OR. So another way, if I want to show it, I can put the parentheses right here. It's just like math, right? Either the thing on the left or the thing on the right, we get a 1 out, right? That's what that truth table showed. Okay, now think about the circuit. What we could do is have an AND. Okay, here's our AND gate, and here's our, that's that first equation. Then we have another AND gate down here with the next part of the equation. And they're going to be ORed together because they're two ORs, right? So we have big old OR gate. I'm going to show it this way, okay? And there we go. And there's no long bar across the very top, so there's no inversion. So we just bring these right into the OR gate like that. And this is going to be our X output. Now, the thing is A, we're going to say A is here and B is here. Okay, and in this gate, it comes up and it goes through an inverter. And the B doesn't. It goes straight in. So there's our A naught B. So out of this one, we have the A naught and B. Okay? A naught and B. So you guess it. When you come down here, no inverter, goes straight in. So there's the A. And you got it. We go through the inverter. And B. Pretty cool, huh? There's a circuit. So there's a circuit for an XOR gate. Pretty cool, huh? Digital stuff is kind of fun. It's like, I had a friend back in college, really smart guy. He called it adult Legos. You know, building blocks for adults. It's kind of fun. You kind of see how you can work backwards from an equation. You come up with the equation from those truth tables. I'm going to show you more, of those kind of circuits, how you can kind of develop that. You're going to see, you're going to catch on pretty quick to this stuff because it really is easy. Maybe at first glance it's not, but once you start playing with it, you'll see. It's kind of fun. All right, so hopefully this video is helpful. Let me know in the comments down below. Let me know in the comments below if you like that better than my whiteboard, okay? Or if you like both for different things. Yeah, maybe there's that case. So, yeah, give me a comment down below what you think. I want to say 2 thumbs up to my patrons. Really appreciate you guys. I got another Patreon last month, so that's awesome. Or this month. We're right at the end of February, so pretty awesome. Hey, by the way, this shirt. The reason I'm wearing this shirt is for my brother-in-law. Rick, hey, want to support him. He just had an emergency surgery on his noggin, and it came out great, sounds like. So really happy. Yeah, it was pretty stressful. Important, you know, him and my sister, they're kind of the glue, you know, in the family. You know, those kind of people in your family. So really important figures in the family. So when one of those people has an issue, it kind of ripples through the whole family. It's kind of tears at the fabric there a little bit. So anyway, seems like it's worked out. He still has some recovery to do, of course, and so say your prayers for my brother-in-law. I appreciate it. Thank you guys for watching, and hope you learned something. Let me know what you think of this digital series. And guys, I think this thing just, I heard something beep off. EcoFlow. I did that in the last video. So I've got a bunch of stuff. Yeah, I still haven't cleaned my bench. Haven't had time. Had a lot of stuff going on. I'm going to talk to you about my job. That's been a crazy month. A crazy month. Some deaths in the family. This, you know, surgery thing. My brother-in-law. This is him, by the way. Picture of him. He's a big-time water skier and snow skier. He's just, yeah, you know, that athletic stud in the family. So, but yeah, anyway, my job situation also. Worked for defense contractors for a while, for a long time actually, and worked for, you know, commercial companies too. But I worked for a defense contractor for about 13 years, and then worked for a couple of startups. And let me know if you want to hear a rant on that. Anyway, looks like I'm back on the road again. Some really great opportunities out there. There always is. So, you know, when you stumble, don't worry about it, because, you know, the road's always good ahead. So that's what you got to remember. So let me know if you guys want to hear a rant about startup companies. Hey guys, before I go, I just want to say there's a super thank you button down below the YouTube ad. That's been really cool. And yeah, the Patreon thing's been super nice, and really appreciate you guys. But liking the video, subscribing, and you know what? Okay, real quick. Some people I've talked to on the channel, they think they're subscribed, they're not. And my wife says she watches a lot of YouTube stuff, and some of the people she watches says that for some reason YouTube is unsubscribed people. They think they're subscribed, they're not. At least that's what the belief is. So if you think you're subscribed, check down below. It'll say subscribe if you're not subscribed. If it says subscribed, yeah, you're not subscribed. So subscribe, okay? All right. Hey, thanks for watching, guys, and we'll see you next time.